Got to give the people, people what they want. Oh, I just hit another octave right there. Boy, I don't know nothing about that. Anyway, 3.4, more work on solving exponential and log equations, all right? So I'm giving y'all some steps, some general steps. We're about to kill this. We're going to do much better on this next test. It's not tomorrow, but we're going to do much better on this next test than the last couple. So first off, our general steps. Don't forget that if you have two logs with the same base and they are set equal to each other, then their arguments are equal. You're like, Bass, what's an argument? Well, if you have the log 10x, if you have log base 6 10x, the 10x is the argument. All right, 6 is the base, log is the log. So if you have log base 6, 85, 85 is the argument. So for this point, right, you got log is the same, base are the same, and they're set equal to each other. That means that these two things, 10x, must be equal to 85. Then you can solve. Boom. We've talked about that, but don't forget that that's true. All right, now, here are your steps in general. 1, condense the equation using log properties if possible. You only want to have one natural log or log term, right? So if you have something like the natural log of 6 minus the natural log of 5 equals 0, we need to get these things together, right? So we're going to use those properties. Those are being subtracted, so that's like the quotient property. So that's the same as the natural log of 6 over 5 being equal to 0. And then you're going to move from there, all right? So anytime you see two sets of logs or two sets of natural logs or even 3, you need to condense them into one. All right, step 2. After you've done that, if you need to, you're going to use algebra to isolate your base with the missing exponent if it is necessary. So you need to isolate a base and a missing exponent. Right? So, right, if we're talking about a base, it'd be like you got to get to something where it's like 4 to the x minus 6, or we got to get this part all by itself. Okay? Step 3. Now you're going to use your properties to isolate the variable from the base. So again, now that we got this part alone, we need to isolate this part. Okay? But then there is something to add on. If you can't do this, so if you can't, rewrite the equation as an exponential equation. And we'll do an example where you see how that works, all right? And finally, after that, what you're going to do is you're going to finish solving using the algebra that you know. So we're going to have these steps, and then we're going to use them for these next few problems. And then this is what you're going to do in class tomorrow. All right, we're going to kill the game. So here, the first one. Wrong. First one. Log base x to 14 equals 3. Why don't you try to solve that thing on your own right now? Pause it, try to solve it. Cool, you just did that. Now I'm going to go through the steps, okay? So step 1 said condense the equation using log properties. There's nothing to put together. There's nothing to condense. So that one is done. Step 2 says use algebra to isolate your base with the missing exponent. So now I'm trying to isolate my base with the missing exponent, but notice like the way that I would get to this 14 on itself would be like the opposite of log base x would be taking it to the x power. Well, we don't want to do that. That doesn't seem helpful, right? If this was anything besides x, if this was a 10 or a 20 or a 6 or a 3, any kind of number, we're good. Because then I could take that number, I could exponentiate to that number. But since that is actually the variable, I want to look at step 3 and do this part where it says, if you can't, rewrite the equation as an exponential equation. So going back, I'm going to say, okay, well, I'm not going to do that, so I'm going to rewrite this as an exponential equation. Well, this means, right, this is a base, this is the exponent, And this is the argument. I'm never going to forget that. I looked that up today and I just learned it. This is called the argument. At least that's what ChatGPT told me. So I'm going to rewrite this as x to the third power equals 14. Well, now I know how to solve this. This is super easy, right? I'll take the cube root of this and take the cube root of that. I end up with x equals whatever the cubed root of 14 is. And you have calculators, and you can figure out the cubed root of 14. Let's see. I'm going to do that on mine. Why don't you do it on yours? We're going to do 3. Boom, boom. Cubed root of 14 is about 2.410. Boom. Done and done. Let's do number 2. All right, so let's look at my steps. Step 1 says condense the equation using log properties. Don't need to do that. Step 2 says use algebra to isolate your base with the missing exponent if necessary, okay? So I say, okay, well, I can use some property. Oh, I don't have a base to isolate, so I'm cool. Step 3 says use properties to isolate your variables. So I'm going to go along and say, okay, well, I need to get rid of the natural log. So how do I get rid of the natural log? I exponentiate it to e, right? So e to the natural log of e, those cancel out. So I'm left with 5x plus 2. And then I have e to the 9th. Cool, cool, cool. So now I have e to the 9th power equals 5x plus 2. All right, so now step 3 says isolate your variable. Boom, boom, boom. So I'm going to go, okay, minus 2. 5x equals e to the 9th minus 2. Divide by 5. Divide by 5. X equals e to the 9th minus 2 over 5. And then that's where my calculator comes into play. Right? I can say, okay, calculator, tell me, what is e to the 9th power? And the calculator told me that's about 8,103.08. And I'm going to take that minus 2. And that is about 8,101.08. And I'm going to take that and divide it by 5. And that is x equals 1,620.21 something, 216, okay? So that is what we did following the steps. All right, so looking at this one, number 3, let's go ahead and go through these steps again. This one's a little harder. I give you props if you try to do this one on your own. I think you can. Go ahead and hit it. Cool. You did that because you got it like that. So let's see. Let's go through the steps together. All right, first, condense the equation. I see some condensing. I see some serious property action that can happen here. I believe it's the quotient property. So let's rewrite this because we don't want log and log. We got to get those together. So we got log base 4. And this is the quotient property, x over x minus 1 equals 1/2. All right, cool. So we did that. Step 2 says use algebra to isolate the base, or we kind of are isolating our variables. 2 and 3 are kind of the same thing. We got to isolate the variables or get closer to isolating our variable. So I got log base 4. I can exponentiate that. Yak, yak. Those are gone. So I'm left with x over x minus 1. And that is, I got to exponentiate this. This is 4 to the 1/2 power. Oh, yeah. So now we still have to solve for x, but the issue is we have an x in the denominator. So we need to get that thing out the denominator. Anybody remember how to do that? Do you remember? Do you remember? Do you remember? Yeah, you do. Hopefully you do. Boom. Let's just take this and multiply it times x minus 1 over 1. Well, what happens? Cancel. Cancel. I'm left with x over 1. So I'm left with x on this side, and I got to take 4 to the 1/2 power times x minus 1 as well. Okay? So on my edge, I would like to do 4 to the 1/2 power. which is, let me just double check, you should know that. 4 to the 1/2 power is a square root of 4, which is 2. So I end up with 2 times x minus 1 equals x. All right, cool. So now I'm just going to use algebra. I'm going to distribute this thing right here. 2x minus 2 equals x. I'm going to keep the party going. I'm going to say, okay, minus 2x minus 2x. I end up with negative 2x equals negative 2. And I'm going to keep using that algebra that I'm not explaining. Boom, boom, boom. X equals, did I do something too fast? Yep, I did. What is my mistake? 1 minus 2x is negative 1. Negative 1x equals negative 2. Divide by negative 1. Divide by negative 1. X equals 2. There is my answer on that thing. That was a hard one. But y'all actually are very capable of doing that. All right, let's hit this last one. This is the last one for the video. Why don't you try to solve this one without me? I think you guys should be good. All right, so you did that. Nothing to condense. Okay. Use algebra to isolate my base. So first I got to get this thing alone, and I can do that. Let's see. I'm going to go minus 7. Go minus 7. So I end up with negative 2e to the x equals negative 6. I still got to get e to the x alone. So I'm going to divide by negative 2. Divide by negative 2. E to the x equals, what's that, a 3? And now I need to isolate x and get that alone. So I'm going to take the natural log of e, yak. X equals the natural log of e with a 3 right there. And then, ln3. And this I can just put in my calculator. What is the natural log of 3? Let's see. Clear. Natural log of 3 is 1.0986. That's just a calculator move. All right, so you all are going to be solving crazy log equations, and you're going to be on top of it, and then you're going to take a test on Friday or the next class, whatever year you're looking at this, the next class after this class that's coming up, and you're going to be awesome. Peace.